Hello everyone, I'm Pei Nan from Beijing Institute of Spacecraft System Engineering. Today, I will introduce you a paper which named Structured Design Method of Spacecraft Telecommand Information Flow based on electronic datasheet. This paper proposed a structured description method of spacecraft telecommand based on electronic datasheet. The collaborative design is realized by constructing command tree. The command tree model is composed of multi-level datasheet, which contain component, container, and interface. A basic component is the smallest unit of command that describe data fields by standard, type, and attributes. The EDI system and general command generating tool are developed to implement the application of the model. It solves problems of incorrect information and understanding differences, reduce the repeated generation and check work in telecommand application, and improve the work efficiency and correctness. The introduce have 5 parts. First, introduction. Second, the process of spacecraft information flow design. Third, design of electronic datasheet. The fourth is application of electronic datasheet. And the last one is conclusion. First part, introduction. The spacecraft system functions, information flow, protocols, and interface have become more and more complex. Generally, design results of the telecommand are described through documents. So there are several problems. For example, data is inconsistent in different documents. Error is occurred in unstructured data transmission. A lot of understanding and input work is repeated. There are some researchers, such as ICDIs, the SOIS Electronic Datasheets, XTCE, XML-based telemetric and command exchange protocol. ICDIs focus on the definition of data interface for satellite-borne information flow, while the CHAR-TCE focus on the data interface between the satellite and the ground station. This paper proposed a structured design of command based on model. Part 2. The process of spacecraft information flow design. The process of information flow design is a V-shaped structure which transmits requirements from top to bottom and collects data from bottom to top. Requirements are passed layer by layer to the final design entity. After the completion of the design, the telecommand information from the entity will be transmitted upward. Part 3. Design of electronic datasheet. First is design principles. There are three principles. Flexible. The exciting protocol design should be covered. Extensible. Future extensions of new protocols should be considered. Structured. The interface state should be machine readable to avoid different understandings. The design of component. The component is defined as the smallest unit. There are 7 basic components, is shown in the figure. The attributes of component include name, ID, length, and type. It's a basic attribute. First, enumerated type. Unit with a finite number of classes which can be extended as interface to lower layer, such as the APID in the packet. The extended attribute of enumerated type include value and meanings. Constant type is a fixed data unit, such as a fixed header in a command. The extended attribute of constant type only contains the value, which is fixed value of the data unit. Check type. It's a unit computed by some algorithms from other units, such as the checksum or date field length. The extended attribute of check type include ranges and values. Padding type is a filling data unit. The extended attribute include algorithm and values. The algorithm describes the filling method, such as filling by even bytes, filling by fixed length, and so on. The field value is the date value of padding. Count type. The unit of date that generates the count, such as the packet number. The extended attribute of the counting type only include algorithms, such as increasing and decreasing, which can be expanded according to needs. Date field type is an unknown data unit, such as the packet date field and packet. The detail of date field type will be described at the lower level. The extended property of the date field type include algorithms used to select whether multiple dates can be included in this date field. User input type. A data unit which value is input by user instantly when the command is generated. The extended attribute of user input type include familiar, date type, and valid range. The value will be obtained by real-time calculation when the command is generated according to these attributes. These are 7 basic components. And then it's the design of a container. A container that consists of an ordered series of components The container can be composed of name, ID, device entity, and interface. Interface connection between containers. Containers are connected through interface shown in figure. The upper layer container contains the data field type unit. The child container selects one key value to form a branching relationship. Part 4. Application of EDIs. The application example is shown in the figure. The application date is packaged in application support layer using the PUS protocol. Telecommand packet of different API IDs is formed in network layer and transferred to data link layer. This process connects the interface and the relationship of different levels, such as this figure. A collaborative information flow digital design platform, which called EDI system, has been developed by CAST based on this model. The EDI system provides information collection, formatting, sharing, change management, and other functions. And at the same time, it provides third-party data interface for applications, including spacecraft software design, system test, and in-orbit operation. The electronic datasheet provides the interface for users. An example of datasheets is in this table. The structured output file is in good agreement with the XTCE definition. The structured information is transmitted to software design platform, subsystem test platform, integrated test system, on-orbit data management system. Standardized command generation tools is developed. The tool can generate commands automatically and quickly. Part 5. Conclusion. In this paper, a telecommand information model is proposed based on layered assembly model. Different types of basic components are collected in data sheet and connected through interface to form a tree structure. The electronic data sheet is filled through multi-levels collaborative design. It solves the problems of different understanding, reduces the repeated generation and check work, and improves the work efficiency and correctness. Later, different levels of interface parsing method can be developed to achieve plug and play and automatic code generation. That's all. Thank you.